Hello, can you hear me? We have about 8 sessions today, so we'll start at 5 and give everyone about 10 minutes. That includes questions. At the end, we'll also have like an open discussion if there are questions or things that people want to actually talk about. It really depends on how quickly we actually finish. But it's interesting that we've got like this room of really intelligent individuals, and it's unfortunate that we don't have. Well, you probably had your own BOF prior to the conference, but it's actually a really good opportunity to discuss things amongst each other in a place like this, to get different opinions and experiences. There are a lot of Japanese people here, and English obviously is not maybe a strong point. So I would ask that you consider them and speak a bit more slowly and clearly. And also for the Japanese, 日本語はあまり上手ではありませんけど、もし質問があればどうぞ言ってください。日本語でもいいです。桜井さんがいますか？あ、よかった。後でもし必要だったら、はい、お願いします。Okay, so we'll start with Kris because we're at 5. Yeah, good. Kris.
Hello. We're going to be just discussing briefly one of the things we're doing in the new version of PCBSD. I mentioned this in my talk yesterday so for those of you who attended it, this might be a little bit repetitive, but I wanted to bring it to everyone's attention. I haven't seen too many people do this in FreeBSD, is use multiple local base directories when you're actually building and running ports, and I've found out there's actually quite a few bugs and issues when doing so. What we're attempting to do in PCBSD, for those who have used it in the past, we would build the system, the desktop, using the traditional user local ports directory, which is great. The downside was when you went to go use your FreeBSD ports installed, they may be older versions, maybe they'll conflict with what you're trying to build and work with, and you'd run into problems building and possibly break your desktop. In PCBSD 7.1, our next release, we're switching to a separate local base for the desktop, which in effect means user local will be left empty after you finish installing PCBSD, allowing you full control and access to the FreeBSD ports tree. You can build, maintain. If you're a port maintainer, a little more advanced FreeBSD user, you can now run the port system independent of the desktop without touching or corrupting the desktop system. Also, this allows us to issue online updates to the desktop without worrying about accidentally corrupting your installed ports. And to do this, we've had to do a few little things to FreeBSD, specifically the ELF loader, allowing us to use a different hints file. And this, again, keeps the two separate, because using one hints file would cause issues when there's libraries in user local that are duplicated in PCBSD local that aren't set up the same. But that's what we're working on. That's definitely a new big feature coming out in the next version. So is there any questions?
What about the database, the port database, the package database? What's installed? Is it multiple copies of that as well?
No. You can still use the same user ports.
Because you might have the same port installed in 2 different.
Correct. You can do that, and we're trying to keep them separate again, because when we ship PCBSD, you may load it 6 months later, and all of a sudden the port's a little different.
Right.
Like, what was that?
RDB packages.
We have a separate directory for that as well. Yeah, so we're overwriting all the defaults. I mean, if you do a package info on the new version of PCBSD, it shows a blank FreeBSD system, just like you installed. Yeah. Yeah, so the idea is you'll have your desktop, you can run it or disable StartX, you can do whatever you want, and it's still there, independent.
Package info, how do you specify which database?
There's some environment variables you can set with package info. I think it's package DB. Yeah, all that good stuff. Yeah, so we're just setting those at our build time. And we're going to have a few commands which allow you to actually switch those on the fly. So if you want to change into the PCBSD local base, you can do that and manipulate ours. Or if you want to switch into the regular user local base, you can do that as well. Any other questions? Yeah.
山で I am interested in NVIDIA driver for AMD64.
Yes?
What's that?
Yeah, I always get this question. NVIDIA AMD64, if you've looked on the NVIDIA forums recently, that's their #1 thread with like 80 pages or something. It's ridiculous. But there's still a couple things in the kernel that need to be resolved before NVIDIA will go ahead and issue us a driver for AMD64. I think we had a list of 5 things, and out of those there's 1 or 2 left. So go to wiki.freebsd.org if you want to follow that list and see what's going on, what the status is. I've heard most of those things, the new fixes are all on 8 already, so as soon as we get those last 2 in, I have contacts over at NVIDIA who, they're like, yeah, we'll roll a driver immediately as soon as those fixes go into 8. So if somebody's a kernel developer, it involves mmap functionality, so have fun. Yeah, go right ahead. Any other questions? Okay.
Great.
Thank you, guys.
Great. Round of applause, please. Okay, that's using style really fast. So we'll probably be moving along. Hopefully we'll finish early. The next person, Antti actually had 4 or 5 things to talk on, but he didn't really know what to put as a title. So I'm going to, that kind of says it all. So Antti? Yeah.
I already got a comment that the title is a bit redundant. I don't know what the person meant, but I'm sure it's all good. So I actually wrote some slides so I would remember what I'm going to talk about. So like Mark said, I'm presenting a bunch of stuff which I haven't worked on. So when Mark asked me to do this, I thought, okay, I'll cheat a bit and just rewrite my suggested summer of code project from the website. The good point in doing that was then I didn't actually have to think what I was talking about. I could just go to the web page and figure it out from there. And the good point for you is if you're interested in them, if you actually want to know something about them, you can either look at the web page or you can contact me. And this is really stuff someone else might work on, I might work on. Really depends on if what I feel like or what someone else feels like. So these are maybe a bit out of context if you're not a NetBSD user, and I apologize I can't go into very much detail about this, but here's the stuff. So the first one is the PUFs backend protocol. People who know what PUFs is, it's the user space file system framework on NetBSD. And when I wrote it, I kind of took the vnode interface or the VFS interfaces, and I kind of just vomited them somehow into user space without thinking very much. And they work, but for example, they expose the vAtter structure into the user space process, which is nice until it changes in layout, which is what's happened recently. So we got a few unexpected side effects. So the project here is either to create exported VFS protocol, which is totally binary independent, so you can actually throw it anywhere if you want, another machine over the network, that kind of stuff. So an evil plot to create a cluster and kind of get rid of NFS, if that makes any sense. Yeah, and this might be a completely senseless project. So, for example, after actually doing it, I'd want to carefully measure how much sense it makes, and if it doesn't make any sense, then just forget about the entire thing. Say that, okay, this is something we don't want to do. We'll just, if we have binary compatibility issues, then that's too bad. So kind of go investigate if we want to go one way or the other. Then this is something I believe FreeBSD already has. Kind of currently, NetBSD still uses the mount system where the argument structure is file system dependent. dependent structure. So the contents are always file system dependent, and usually they happen to contain exactly one argument, which is the device path. And well, to say a few words, in NetBSD we can run kernel file systems in user space as part of application processes. So this limits the usability of kind of the vnode interface, or using the vnode interface in a user space process, because you actually have to know how to mount the file system. Once you get the file system mounted, then you're set. But until you get the file system mounted, you need to know things about the file system itself. So kind of that destroys the abstract approach. Then in NetBSD we have questions.
Basically, previously what we have is that there is a common function, I suppose, nmount, which actually calls the sum overload function, which is per system specific. So you simply can handle the general part and the system specific part transparently without any other problem.
Yeah. I want to do.
What you want to do.
Yeah, something like that. So FreeBSD probably is or should be looked at for that part. So then in NetBSD we have a tool called MakeFS, which you point to a directory structure and it builds a file system image for you. And this is used by the NetBSD build.sh, so we don't have to have support for VND on the build machine. But this is currently implemented so that a bunch of for one, it supports only FFS and CD 960 currently, and it's implemented so that, well, for FFS it's kind of the kernel code modified a bit and then tossed into user space, and for obviously for CD 9660 the kernel code doesn't support writing, so it's completely rewritten. But anyway, since we have the ability to run the kernel file system code in user space, we could actually convert the MakeFS utility to use it, and therefore gain support for all kernel file systems, which we have support for. The problem is that you still need separate code to create the file system image, but then to populate it, that could be handled completely independently. Then this is another weird project I have, since we can run file systems in user space, do a service layer for them. So you have your file system running somewhere, and you can advertise your file system, and people can go around and discover where you actually have file system services. And this is once again something that might make sense, or which might absolutely make not sense, but this is kind of along the lines of a distributed cluster thing, weird system. And then finally something which I do think makes full sense as opposed to the other projects is describe the system interfaces with XML instead of writing them as C headers, and then just generate C headers from them, generate manual pages from them. You can use it to do static analysis, so this interface takes only flags of this type, and then you can check your source tree that it actually does so. And if you listen to my talk this morning, then you know something else that I would want to do with this, which is make the kernel interfaces accessible from or the NetBSD kernel interfaces accessible from non-NetBSD systems. Okay, that's it. Everyone is back row is clapping very quickly, so I guess that's a hint.
No questions? Okay, give a round to Antti, please. Okay, while we're setting up here, I forgot to introduce myself. My name is Mark Toraki Uemura. I'm known as MTU amongst the OpenBSD community. And the next talk is going to be interesting in that if you've ever gone through a denial of service, this will be very, very interesting for you to see. David?
Unfortunately, Mark stole my thunder. I was going to say, while my lovely assistant sets up for me. It's not going to work, unfortunately. A bit of history here. mclgeti in the kernel is an interface which allocates clusters for network use. I remember at the last hardware hackathon we had in Portugal last year, I was walking back to the hotel in the cold with Theo and Claudio, and we were talking about how we could generalize it for use for jumbo packets, i.e. packets bigger than 2K. This whole infrastructure grew out of that, but it's grown into something completely... the fact that it can produce jumbo packets is quite irrelevant now, because we can do other stuff with it. So, if anyone knows the kernel internals, basically your hardware at the bottom there, it receives a packet and it copies it into the kernel. It generates an interrupt handler. That hardnet handler then allocates another mbuff, puts it back on the hardware for it to use, and it sends the packet received up the stack. And it just does that over and over and over again. At the end of that, when the hardware's finished with and the kernel's finished queuing it all the way up, it copies it out to userland. Now, the problem with this is if you suddenly get the hardware issuing a huge number of packets all the time, you'll spend all your time in the kernel simply pushing packets up until you get to this problem here, is that the buffers for the userland to process will fill up, but you're still receiving packets from the hardware. So at some point you're going to have to drop the network packets. This is a denial of service. Has anyone experienced this? Yeah. You haven't? Yeah. So what can we do? Well, the trick here is currently in all our network drivers, or previously in all our network drivers, you have a receive ring which you fully populate with receive descriptors. In the case of the hardware I'm going to talk about, the Intel Gig controller, in OpenBSD we allocate 256 descriptors on the ring, and we guarantee that it was always filled. So all the time 256 descriptors were on that ring. The problem with that is there's always going to be memory available for the hardware to denial of services with. So what we do is we shrink the number of descriptors on the ring when we detect that we're not able to pass the packets back up to userland. So we have a simple detection algorithm. It basically says if the soft clock doesn't tick for a couple of events, then we're in live lock, and we start to shrink the ring. All right? Does that make sense? Eventually, we'll not get enough packets off the hardware because it's simply dropping them off the ring, and we'll be able to get back up to userland and move the packets up. I'm not going to do the interpretive dance. Claudio was supposed to do that for me. But the basic heuristic we have is when the interface first comes up, we only put 4 mbuffs on it. That's it. As the system gets busy, and if you take all the packets off the hardware, like all 4 of them, we'll give you one more cluster to put back onto it. So the next time you have 5 packets, if you again use all 5 of those, we'll let you put another one on, and so on up until you have a usable and an appropriately sized mbuff ring for your application. What happens is it will get to the point where you can fill that ring and spend too much time processing it. So when we detect that with the soft clock detection there, we just halve it immediately. If you're still suffering 2 ticks later, then we halve it again. And once you're able to get some CPU time back, we let you grow it one by one as we go. So the other cool thing about this is because the rings are so small now, we save a lot of memory. Like I said, EM used to have 256 descriptors on it. On my really busy firewalls at work, I have 2 EMs and they're using 66 mbuffs between them. So I've saved a quarter of the memory, which is a fraction of the 512 kilobytes or a meg I had on there. So that lets me put more routes in there, it lets me put more firewall rules in there, it lets me put more states in there, it lets me do other things. The problem with it is we can't switch all the drivers over in one go. because there's hundreds of them. We have 100 of them, and we can't do the work in one fell swoop. So the API, the previous one, mclgeti, still exists. All 100 of the network drivers still use it to a large degree. The other problem is, because of the heuristic that you have to keep the RX ring filled, there are significant mods to the drivers to use the new API. The driver now has to cope with you only having a small number of descriptors on there, has to cope for when it gets exhausted by the system using it, has to know, it has to have an event where it can restart putting memory on the rings. Yeah, I've done 2 drivers now, and it's probably like 150 line diff to each of them. And there's been bugs in every single one of them, which I've worked through. The other benefit, though, is, like I said, significant memory savings. The new allocator takes an argument saying what size packet you want, so you can ask it for a 64K frame now if your hardware supports it, and it will try and give it to you. We just have several pools at the back end which it allocates out of. And most importantly, despite the fact that this started for jumbos, we have functional live lock mitigation. Now, I have denial of service my box at work. I got pfsync to talk too fast to each other, and instead of absolutely hosing the box and preventing me from fixing it, it gave me 5 or 6% of the CPU back so I could actually do something on it. Otherwise, I'd just spend forever sitting in SPLnet, taking packets off the hardware, putting them back on, taking packets off the hardware, putting them back on. Yeah. And yeah, that's mclgeti. Any questions? No? Well, the next step after mclgeti is automatic interrupt mitigation.
So that's nice. So now basically, when a huge flood is coming at your machine, we can step back and drop the packets very early on. Unfortunately, there are still some components that we can improve. Or fortunately. So this diagram over here shows how the system actually works with older Ethernet cards. I'm going to compare older Ethernet cards to newer ones. What I'm looking at here is the control flow. Original Ethernet cards would only basically give you 1 packet per interrupt. So you would end up in the interrupt, you would get it in your interrupt handler, and then you'd move up the queue and service a packet. But let's say maybe you were up over here and you moved the packet up to the socket layer, and an interrupt happens. You don't return that to user land. What you do is you go right to service the interrupt, and you take another packet and you put it onto the queue. And since you now have some time, you finally succeed at running userland code and move that packet up to userland. Your next interrupt does the same thing, puts another packet down onto your queue, which moves up onto your sockets. So in this model, of course, you probably can't be denial of service very quickly because you're limited by how many packets you're going to get from your cards. But your interrupt rate is very high. So what all the vendors did is they added interrupt mitigation. Most of the interrupt mitigation hardware on these chips is actually essentially a timer. This timer is used to is started when the first packet arrives on the card, and the timer goes tick, 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 and at a certain time later it decides enough time has expired, I'd better tell the operating system. What happens in this case is that your interrupt handler now copies a whole bunch of packets up to the socket layer. And then you receive another interrupt, and you get a whole bunch more packets on the chip, and you copy them up into the socket layer. And then you try to go run some userland code. But just as you start to run that userland code, you receive another interrupt. And now you've copied too many packets up, and userland is barely able to process them. So while mclgeti is controlling the sizes of the rings, we are still receiving too many interrupts. So interrupt mitigation helps for one problem, but it also hurts another problem. One of these problems is that our latency is now getting really high. We're pushing packets up the stack, just like in the previous talk that David did. We're pushing them up the stack, but eventually we're not going to be able to service them. So this is what we are working on trying to do. We want to take this interrupt mitigation counter and adjust it dynamically. So basically we would start off with low latency. The default that we have in some of our drivers right now, like for example EM, is the timer is set for approximately 8,000 packets
800 interrupts per second. Okay? This will allow quite a few packets to come in at a time. Unfortunately, if you convert that number the other way around, you discover there's a fixed offset from where the first packet comes in until your host services it. Then you receive that packet and immediately transmit it out again. For a service like pfSync, if you've seen David's talk, it's actually really critical to handle some of these packets very quickly. So if there isn't much traffic, why are we setting this latency timer to a high value? Why don't we take a completely idle machine and service the packets immediately? So the idea is that the latency timer would basically be set very low normally until a large amount of traffic comes in and indicates up at the very top to us that we're not able to process these packets up in userland. At that time, what we would do is we would increase the latency timer to force more packets to hit the chip. Simultaneously, the mclgeti interface would be removing the amount of packets that can actually be put onto the ring, so that the Ethernet card would be encouraged to drop packets for us before it even DMAs them into memory and passes them up the stack. That's what should happen. Eventually, if userland is able to keep up with the load, the interrupt mitigation time would be moved back to low latency. So we are still on the search for a heuristic. In summary, once again, we have the same problems and the same benefits. We have 100 network device drivers, and we don't want to break any of the existing drivers. So we are working very hard on trying to ensure that the interface we build is easily adaptable to drivers. I think we're working even harder on that after the experience of what it takes to actually put mclgeti into existing drivers. We want to find an easy way. Hopefully it'll be minimal modifications to drivers. My test case right now is a modification to the EM driver, which changes 2 lines in the EM driver. It may not be that simple later on for some of the other drivers, but we'll see what we can do. This will save time in the kernel. Unlike the other change, which saves space in the kernel, this will save time. It will mean that we can get packets in and out of the system much quicker, and it will ensure that userland has more time in situations where denial of service is happening. Essentially, this also has a bit of live lock mitigation in it as well, because packets in flood conditions are dropped very early on. Okay, are there any questions?
We're really good at this.
Yeah. Okay. Okay. Thank you.
Is Kristaps here?
Yeah. I have no slides.
That's fine. Of course.
So, can everybody hear me? I'll be pretty quick because I don't have that much to say. But some of you may have gone to it, some of you didn't maybe. But I presented a parser for mdoc macros, ostensibly to display manuals to the screen. And this is going to talk briefly about that. It is being merged into the OpenBSD system under user bin mdoc, probably. This is going to happen in the next few days because CVS has to be spliced in. So we wanted to have a enter showing it being merged, but that may take a little bit longer depending on how messy my change logs are. So we'll see what happens there. But it's going to be there. Right now, it already has pretty good support of the existing manuals that are there, both on OpenBSD and also on NetBSD, actually. I haven't done any testing myself about FreeBSD, although there is a port done by Ulrich something, I don't know. Right now, just mdoc term exists, which prints out nroff backspace stuff, just like nroff does. The work in progress for that is both an mdoc HTML, which ostensibly could be used as a man.cgi that properly formats the output instead of kind of hand-waving it, which it does right now. Another tool that is done is mdoc lint, that is able to fully lint your manual pages to make sure that they comply with what they should be doing in terms of the mdoc.7 and mdoc samples manuals that are there. And that's all I have to say about that. Anybody have any questions? Yes?
Are there plans for a mdoc PS or some other?
Yes, Durmaus actually might be doing mdoc PS. He actually offered, so I don't know if he's going to end up doing it, but that would be nice because apparently people use that facility more than I thought originally. So that is certainly going to be in the works in that case because that it is in the build system.
And all this is written in C, not
Yeah.
C++.
It's all. It's what's that?
How many lines of code?
It's a little less than 10,000 lines of C code for all of it. For the lint tool, there's another tool, a debugging tool for printing out the tree, the parse tree, so you can actually see what the parse tree looks like if you need to fix things, and so on and so forth. Graph is in the old graph in OpenBSD is over 5 meg of source, and in terms of just C++, there's over 60,000 lines of C++. So that's not even counting C that's intermixed with it, or all of the PS stuff that's also stored in there too. So it's a huge package. I don't know how big it is on NetBSD right now. It's probably a lot bigger because it's a newer, and these things tend to get fatter over time instead of slimmer. Also rewritten our mdoc 7, so it's now a language reference instead of a kind of hand-wavy reference guide, which is actually incorrect in several places. So that's all fixed. Is there anything else we wanted to talk about with that? No more questions? Oh, there were questions asked during the presentation about multilingual inputs. No. Multilingual outputs, maybe later. It's certainly possible because it's just another output filter. The backend is a compiler, so pretty much any front end can be written for it. HTML, PS, and terminal stuff, those are just ideas. It could be UTF terminal, whatever you want. The mdoc 3 manual page has an example of a front end. It's about that big. It uses fget line and pushes it into the compiler and gets the result. So it's really easy to write front ends for it. One more thing is that it also, at least in OpenBSD, will install the libmdoc, so you can write your own. It'll be in the system. And that's pretty much it. I think that's all I have to say about that.
Any more questions? No? Big hand to Kristaps. Rafal? Oh, this works.
Yeah.
I saw Kristaps' presentation just before this, and it's really great work that everyone can actually benefit from. So if you're interested in man pages or you work with that stuff, you really have to see his presentation and read his paper. It's really fantastic. Thanks. Great.
Did this work? Hello. Let me spend a few words about FreeBSD PowerPC update that has been for some time in the background. So first of all, there is a ongoing work on a PPC 440 and 460 work for FreeBSD, and if you have followed my yesterday's presentation, the AMCC and other variations of the 440 and 460 are Bookie compliant PowerPC specification machines. The reference platforms that we are running now are AMCC, Glacier, and Canyonlands. These are reference kits from AMCC. They are basically the systems from AMCC, and other vendors are SoCs. So we've got a number of peripherals integrated on the same chip beyond the core CPU. They are mostly single core. I mean, all of them currently are single core. There are upcoming dual core too, but they are not available yet. It's like they are expected sometime mid of 2009 or even later. So current state of the work is that FreeBSD 8 current is working up to we basically boot up into multi-user. We can we root file system mount root file system from USB device, and and it's working pretty stable. We can do self-hosted kernel and world builds. A couple of items that had to be done in order for this to work was, first of all, we needed to adjust toolchain, the entry, GCC, and bin utils to produce proper PPC 440 code, because there were a couple of tweaks required. Other than this, we worked on the initial kernel routines, and also PMAP had to be slightly adjusted. Other than this, the rest of the code was inherited or is expected to be shared with the pooka support for Freescale parts. Some new development was regarding bringing the interrupt controller driver and also the bus attachment for the existing OHCI and HCI drivers. So, any questions regarding this part? So the other item that I wanted to mention is also an embedded system on chip device, MPC 5200 from Freescale. So it's some lower end machine. It's the traditional PowerPC, unlike the pooka. It's E300 core in Freescale nomenclature. It's mostly used in automotive environments. It's profiled. It's got a couple of peripherals like CAN bus that make it suitable for using in cars or other environments like that. We use a reference platform from Genesi, Fika. It's very small board. It's very cheap. You can buy it for $100 US. It's very it's easily available. MPC 5200 is very widespread. You can find a number of devices other than Fika on the market. With this, one of the things that isn't mentioned here is that the work mentioned now is a continuation of the Google Summer of Code program from last year. I was mentoring a student who did the groundwork for this, and this is now being continued on. So, but with some other person. We currently can boot the kernel into single user. We've got initial shell prompt with memory file system disk. There isn't much support for the integrated peripherals. It's just the basic stuff like the low layer for the PSC, the serial controller that fits into FreeBSD Raadt driver. So the serial console works. We also brought up interrupt controller driver. So just very basic stuff. Other than this, just kernel init routines and just open firmware glue. The Fika in particular is a bit different than other open firmware based devices in a sense that its open firmware implementation, smart firmware as they call it, works in real mode. Unlike Apple's, for example, Apple's open firmware on PowerPC, so it gave additional work, and because of that, as some context need to be kept and restored when switching between open firmware calls. So, but that's all done, and we are well positioned to do other elements missing from support. So that was mainly it. Are there any questions? If not, then thanks.
Brooks?
Thanks.
I'm Brooks Davis. I'm going to talk briefly about the status of LLVM and Clang, building FreeBSD. So first off, this work is really more work by Pavel, Ed, and Roman, none of whose last names I'm going to mutilate, who have been doing most of the work. I've just been producing snapshots of the system. LLVM is the low-level virtual machine. It's a compiler toolkit and just-in-time compiler targeting a wide range of architectures. The most stable ones, since much of the work is done at Apple, the most stable ones are platforms Apple cares about, which means i386, AMD64, ARM, and PowerPC. But there are also MIPS, 32-bit SPARC, and IA64 ports. There's a cell backend in progress, and that sort of thing. On top of that, this is all BSD licensed system. One gotcha is it is written in C++. Clang is an attempt to write a C, Objective-C, and C++ front end for LLVM. Right now there is some code that uses GCC 4.2 and converts that into the LLVM intermediate representation, so you can use that to compile C code and then do LLVM processing on it. But Clang is a complete rewrite to do, or is a complete from scratch C compiler. And so they've been making really rapid progress. They announced it about a year ago, and at this point it's compiling meaningful applications. So FreeBSD, the FreeBSD kernel boots on i386 and AMD64. With, I think the only current exception is there's one kind of ancient Raadt serial driver that has some code in it that doesn't work, or doesn't compile. But otherwise, the whole thing compiles and builds, including lint. So let's see, that's the status. It also builds other fairly large C applications like GCC, GTK. I believe somebody actually managed to build and run Firefox. So fairly big stuff working at this point. My understanding is they plan to have it sort of product ready within the next quarter or two, possibly shipping in Xcode, although Apple, of course, does not pre-announce products, as they tell me every time anyone asks. Let's see, beyond that, they're targeting, as with most of these projects, they're targeting standard C, but plan to support essentially all of the sort of bizarre GNU-isms because there's so much crappy code out there that isn't going to get fixed. Let's see, what else? In addition to being a compiler, they also have static analysis tools as part of the Clang build. So they're pretty basic at this point, but they are finding real bugs and doing useful stuff there. They're also targeting much more useful error messages. So, for example, they give some examples where they show an error and you see the usual GCC output and there's a type problem. With Clang, they actually mark which character is the wrong, is where the error occurs, or which cast and variable are wrong. So nicer output, that sort of thing. It's coming on quite nicely, and we're sort of, actually Ed started this weekend working on a bmake code. I don't imagine we'll bring it in for 8, because at this point it's not self-hosting, because the C++ is probably a year or so away from being able to build itself. Any questions?
How about the compiling time against GCC?
I don't know that we've actually compared that. I think either Ed or Roman looked at it, but I haven't really looked. I do know that performance-wise, the resulting kernel, if you run, say, libmicro, we're not seeing substantial differences. There's differences, but there's some are plus, some are minus compared to GCC. Yeah. So performance-wise, it's not way out there. Any other questions?
How's build time? Like, the difference between builds? Or do you don't have the numbers for that?
I don't have the numbers.
Is it slower than GCC4? Like, building stuff?
No, actually, it's generally, well, right now, the compiler driver is in Python, so it really bites. So you have to invoke Python, and then you go off and run all the programs that do the work. But that's being rewritten, and if you factor that part of the time out, I gather compilation, they're targeting at least 50% faster than GCC, because Apple wants to use the library interfaces to the compiler within Xcode, so they'll do syntax highlighting and parsing and generate real-time errors as you type. So they want it to be extremely fast and quite lightweight. And I gather they're doing periodic testing with, I think it's Coco.h, which is the giant include from hell that pulls in something like 10 megabytes of headers. And they typically are producing quite a bit faster code and much smaller parse trees. But I don't have specific numbers, and they wouldn't really be fair with the Python driver. Anything else? Thank you.
Well, moving right along. Gee, we're really moving right along. I should have said the limit is 5 minutes. I wonder what would happen then. Is Andrey here? Yes. Andrey is going to discuss some of his work that he did with the Russian police.
Hello. Once this winter, I have got from Moscow State Traffic Inspection a very interesting device. It was in a box with Word CDMA modem, but if you connect it to FreeBSD laptop, it will say it is CD-ROM drive. It happens to be a switchable USB device. After turning on, it is virtual CD-ROM drive, but if you know how to reinitialize it, it can become modem and connect you to the internet. Of course, the device was designed for Windows, and that virtual CD-ROM contained the device drivers for Windows. But I think they are pretty useless for our FreeBSD system. But our friends, Linuxists, has solved the problem with this device. They wrote a special program, USB mode switch, which uses libUSB to send the magic sequence of bytes to the device and reinitialize it into the modem mode. But with FreeBSD, it didn't work, because libUSB under FreeBSD works with UGen devices only. So we have at least 3 different methods of getting the device to work. And I think the first 2 are not very interesting. Well, we have at least 4 methods of using USB mod switch program, or another method of reinitializing device. But the first one is unacceptable, because our Brave inspectors mount a root file system from USB flash drive, so UMass driver can be disabled. I've tried the second method. Used a special quirk ignore device. If the UMass driver sees it, it simply doesn't connect to the device. It becomes a UGen device. So libUSB sees it, and USB mod switch switches the modem into its modem mode. Well, the third and the fourth methods I couldn't test, because after the second approach worked, our brave policeman said hooray, and have taken the device away from me. So the work has been stopped here.
Any questions?
How about with USB 2? Did you try with USB 2? USB 4 bits, USB 4 bits.
I have a formal task to make this device work under FreeBSD 7 or FreeBSD 7.1. This version don't use USB 2.
On USB 2, using always exists. So you can use USB.
Well, also, I think Hans has one of these devices as well. Hans is the author of USB 2. And he does special things to match the CD-ROM devices, reinitialize them, and have them attach as modems or whatever as well. So he has added some support in the kernel for that in USB 2.
Yes, but I couldn't use USB 2 because of the task.
No, I understand.
What we do in OpenBSD is our UMass driver matches UMass type devices by their class. But we have a bunch of serial USB drivers that now match these devices specifically by their vendor and product ID. And then in the attach sequence, they know that these devices are quirky in this way. It looks like at the moment there's 4 types of these devices that are a little bit different from each other. And the simplest one is fascinating. All that you have to do in the match routine is once you've set up in the attach routine of the serial driver, as soon as we set up the USB pipe and we know it's this device, we actually send it a SCSI eject sequence, and it disconnects from the bus and comes back as the proper device. So that's one of these types, but there's 3 additional ones, and there probably will be more as time goes by. So that's how we've been dealing with it, simply using the priority subsystem, the priority scheme that's in the auto configuration subsystem. It considers more specific matches by product and vendor to be more significant than the class of the device. So this has helped us get around this problem. And that work was done by Kuchero. So good luck.
Thank you.
Is Attilio here?
I'm sorry if I didn't prepare any slide, but I will be very short. I would just wanted to speak about some improvements to the FreeBSD VFS I'm going to work on. Mainly, the first item is to, as long as our VFS is pretty much complicated about the rules that are not written and should be followed in any case, one of these is the usage of some writing barrier on when there are going to be some writings on the mount point, for example, and this barrier should be set manually outside of the file system specific invocation for writing. This is very error prone because rules are not well defined about when to call this, and a lot of new implementers we found that didn't know this rule at all. The main problem is that it's a technique that it's used in order to not create races with the creation of snapshot in the FFS, for example. But the support should be but supported at the VFS level actually. So one thing that Jeff Robertson already did is to embed such kind of checks on the FFS snapshot creation, directly in the locking primitives for example, vnodes. But there were some problem that actually I think that Kirk pointed out. For example, in some places there were not vnodes locking that was going to prevent races on the snapshot creation, like lookup I think, and rename. So we had to fix. We should have to fix some such places in with the explicit barrier, probably, or in other ways. And also the work that Jeff did was still maintaining these write barriers in the VN lock, for example. So still at the VFS level, while probably as long as it's an interesting feature, it's also just used by all this time by FFS only. So probably the better thing to do is just to move the support directly in the FFS and completely remove from the general VFS. But I think that the biggest part of the work has already been done by Jeff, and I'm just going to fix that so that we can remove the barriers called VN start write and secondary writes and suspend those. Say that there are improvements we are going to make to the VFS, like making the name cache scalable. It's not very simple at the moment because the name cache in FreeBSD is generally ended with an hash table. So the first thing we thought was to protect the hash table with a lock per any queue. But the biggest problem is that vnodes, you actually track down the name cache linked to parents and children in order to implement things like cache purge or, for example, VN full path. And the locking is going to be pretty tricky for that because they don't know anything about the lookup operations like father, like the parent, the pointer and the name of the object. So they actually just will need to lock scope which is bound to the vnode. I started locking them by using the vnode interlock, but then I found that there are some block order reversal with the general hash locking queue that we are going to use to protect the general hash table. So it's going to be very tricky because probably we have to change the algorithm cache purge and full path works actually. Then these are the biggest work we are going to face. That's not very trivial. Another thing nice that probably would worth to mention, but I'm not sure how much benefit is going to bring, would be to rewrite NAMI interface in a more smart way. It's I think it's pretty much unchanged by the first one that was implemented. I think I have read the Valia book and it's still the same, probably, yeah. So the end init and the subsequent NAMI probably should need to be merged in something more smarter. I think I saw a proposal from the NetBSD mailing list that was pretty interesting, but actually I don't recall details. I would like to see again that emails. And that's all.
Any questions? No? Okay, well, thank you very much. Okay, the last presentation is by Uebayashi-san, and I have to admit that he was a bit shy to do this because it's actually, from my understanding, for me, it's second time actually to make a presentation in English. So please be nice to him, be gentle, and encourage him. Thank you very much, Uebayashi-san.
My name is Masao Uebayashi. I talk about reproducible build. As the name suggests, it's a build procedure which is modified so that you can get exactly identical outputs repeatedly. It's also called deterministic build. I actually didn't graduate computer science department, and I did not read compiler text, so I cannot explain the notion correctly, but my understanding is non-deterministic in computer science means more than one goal is accepted. It is correct. For example, in make command, it has some rules. If you want get foo.o, and if you have foo.c, cc builds foo.o from foo.c, but you happen to have foo.s somehow, it may build foo.o from foo.s. This and this are two of them are both accepted. And VFS NetBSD has a script to build a whole system by one invocation. VFS builds a whole system, including cross-compiler, library commands, kernel, and install images, everything. And if you run twice with sh with exactly identical arguments and using same source tree, you will get the same results. Yes. Actually, no, a slightly different output, because in some parts are timestamps and some random numbers are embedded somehow. Skip. Your software product is made from many components. And if you find a problem in the result, final result of a product, and you have to find the code and try to rebuild fixed one. But if part of this build procedure, for example, here is it's not deterministic. For example, it embeds timestamps. You cannot reproduce old bad binary. You can never reproduce it. That's not good. Skip. So Perry raised this question last, I think, September or so, and in NetBSD, most difficult parts are already addressed. Timestamps in archives embedded timestamps, and CGD fixed that, and some C++ objects contains random numbers, and it was found that some option, if you give some options, it's constant. It gets constant and no random numbers. And third absolute passes are not necessarily related, but this is practically useful. People use different source code paths, and if comparing those outputs, you can get that. Actually, achieving this goal is not very difficult. So just do it or not. The motivation. I want to I want to convince people that so that all of you agree this is useful or not today. It's idea skip no time. Okay. Yes, I worked for some companies, and all of them are small companies, except IIJ. Yes, we had problems. We had problems that, unlike such big company and good release engineering team, that problems we had recent money, and which in turn means we had shorter time, and we had bad customers, and I had to achieve goals which customers want in unreasonably short time, and in such a situation you cannot release ideal products. So you have to release incomplete products. That's sad, but it's real life. Okay. Especially embedded development involving hardware, you face many problems like this, and your product does not work if it's located on stable disk, but if you move some in such a situation, it starts work somehow. It looks like CD, but it's common situation in embedded development, and you have to figure out the real problem from such a situation. So now this is slightly off topic, but I would introduce you some techniques, embedded programmer techniques developed in Japanese engineering community. This is introduced here, and I translate. I think some of you know this. I think this is useful for some of you. So, perfect. This is one of the easiest technique. If you say perfect, the problem, the responsibility of problem moves to hardware engineer. This is most easiest, most simplest technique which you should run just after compiling Hello World. This is you can use this technique unlimited times. Okay. On-site debugging. I'm not sure this is sensible English, but can you understand? Okay. So cheap developers don't have enough time. So just deliver the product to the customer, claiming, yeah, you fixed, you tell the customer that you have fixed all the problem, all the bugs. Just you had not enough time to check and debug it. This is a very useful technique. And if you once learned this technique, you can also use more useful technique. You had no time to debug, say, and develop it. This is, of course, yeah. This one is the most difficult. If customer tries to use the product, it does not work. If you touch the product with deep rub, it works. Okay. Yes. If you get more experience, you can even transmit deep rub remotely. Yeah. Okay. This is only used by most highly experienced engineers like me. Okay. After a long debugging, you have finally found the most suspicious part, like this. You try to ask Mr. Maeda, but he quitted the company 10 years ago. And no one knows his name. Mr. Yoshida already quitted a long time ago, and everyone knows his name, but no one wants to talk about him somehow. It's very common situation. And if you touch uncomment around here, the behavior change, and you now have a clue. You can debug further. And after hard on-site debugging, you have decided this is the best solution. This is funny, but not so funny. It's real problem. He knows. He agrees. This is very common.
True story.
Yeah.
You can't make this up.
So in such a
we've all been there.
sensitive situation.
There is a problem with the hatch. You have to put your name and the date in.
No, I intentionally did that. Yeah, anonymous. Okay, in such a situation, if such a sensitive situation happens, binary, you don't want to disturb resulting binary. If you add if the resulting binary includes unintentional change. The behavior may change. Unintentional change may occur. That's not good. Release candidate. And now you have to create release image. Usually release, if you decide the source tree is enough stable and very close to the production, you make a release candidate. And if you find a bug and fix, a next release candidate is created. If release candidate number n is stable and no bug found, no bug visible to the customer found, you decide to release. Okay. And this is the last release candidate and the release. The last release candidate and the release is same and not same. It's same. It's not same because it should have two different version numbers. Otherwise, your customer cannot make sure it's really release firmware. It's same as in it behaves exactly identical behavior. 長いですか? So if you use string returns, it may disturb binary. So let's use fixed strings. This is just one example, but I think all of you get the idea. So conclusion is remove unnecessary difference in the result binary. And I think now all of you are convinced that reproducible build is useful. Yes? Who is not convinced? Raise your hand. Okay, thanks. The last thing I want to say, I want money. I started a company last December, but this is very bad timing to find a task, so anyway, the thing I really want to say is thanks for supporting and coming to AsiaBSD conference 2009. Thank you.
That was fantastic. Thank you very much, Uebayashi. And I hope that the release engineering that you've learned wasn't from IAJ going to their products. I'm sure it wasn't. Actually, some of the most interesting and funny talks that I've seen come from Japanese presenters, just like Uebayashi-san. So I would encourage for next year that you step up. And it's a strange thing. Like Theo always asks, whenever he goes to Japan, and it's question period, there are no questions, unfortunately, from the Japanese people. And it's only in Japan. Doesn't happen in Taiwan, Malaysia, China. It's only in Japan, and it's a strange thing. We know that you're really very, very intelligent. We have a lot to learn from the embedded engineers. There's a lot of embedded engineering people here in Japan. So what I'd like to do is open up the floor right now, because we actually did do fairly well, except for the extended talk with by Uebayashi. But is there anything that anyone would like to talk about or discuss now for a few minutes?
Oh, what discuss?
何でもいいです。はい。日本語でもいいです。通訳とな。No? I mean, here we have like some really great minds. You can. Yes. Saiko-san. Come, please come up. Come.
I want to talk about English, but I'm sorry, I'm not good at it.
So, you don't. Where's Sakurai-san? Where's Sakurai-san?
So,
hurry.
Start in Japan. OPSD guys talk about the problem that Ethernet queuing. It's very big problem. We must to solve as soon as possible. The reason why is, for example, IPsec key is committed with user and in user rank is running and current key. When we get attack from other, for example, short packet get so almost flagging in kernel side, and we couldn't run in user land. So if so, IPsec connection will break. It's very important. And for example, routing socket is the same problem. So we have to solve this problem as soon as possible. I want to know how many people notice this problem. Yes, and I tried this problem for many years, and I want to share this problem, and we must problem as soon as possible. Please talk about this problem if you want. Please, I want to discuss this problem.
Good. Thank you. Great. Claudio, hurry. Come, run.
So, we in OpenBSD, we just started something with the routing socket. The problem with the routing socket is that everybody who listens on it gets all the messages, but like most applications are normally not interested in most of the messages that come up. So we have DHC client who is actually only interested in like interface state changes or new addresses on an interface is configured. But at the same time, it's getting all the other traffic from like when you have a BGP server running on it or something else, when you have a lot of route misses, you get a lot of messages up. And I have seen systems where like DHC client suddenly was like taking 20% of the CPU time just to dump all these messages on the floor because it's interested in it. So what we did is we implemented a routing filter message. We have now a socket option so that we can filter messages based on their type, and DHC client can now tell the kernel that it's only interested in specific messages, and everything else is not sent to that daemon. And by doing that, we can save a lot of CPU time that is wasted just for nothing.
The reason this is becoming important, in OpenBSD, we want to start making many daemons aware of interface changes, so that you realize then that the addresses have changed in dynamically configuration environment. So the only way to do that currently is by listening to the routing socket. So it's not just DH client.
Yeah, there is other programs like bind NTPDs and all the UDP clients that need to listen to all interfaces so that they can send the packets right back. They're all normally listening on the routing socket, and you actually don't want to have them getting all the messages. It also helps in the other thing that we plan to do is to be able to lock it down so that we actually can say these demons are actually not even possible to get some messages. But that's not yet done.
What would you use that for? These demons don't get...
Like, that you cannot like change your filter settings afterwards. So that when like somebody comes into your box and tries like, he's able to get into bind. He doesn't see what other routing messages you have.
Okay.
It's not possible that you can send messages into the kernel. They will. One problem is you could actually send RTM gets into the kernel and get answers right back, but you actually don't want to have that possibility.
I have to add that after discussing this with Claudio, Theo, and David, that the thing that they're actually working on right now, the work in progress, the 2 talks that they made, is actually one of the biggest paradigm shifts that OpenBSD is actually doing in the past 5 years. It's a really big thing, and especially for maybe the people who are doing embedded devices. This is really, really important for you because how often, when you're working with really underpowered CPUs and network cards that are not, your BGE or your EMs, for example. But this is a case where we're trying to actually stop from being denial of service, so that you can actually work on the console and fix a problem. Because right now, as it stands, you can be denial of service, and there's nothing you really can do about it, especially on these smaller underpowered boxes.
When I put I have the Intermediation running on my laptop, and I also have the ring dynamic ring side. And when I put my export laptop to 600 megahertz, over gigabit Ethernet, I cannot make the machine unresponsive. So that sounds okay. Now, when you take like a little Socrates, what's that, 233 megahertz 46?
Yep.
With 300 megabit Ethernet, we can make that machine interactive at full flood now. That's without intra-mitigation. That's only using the dynamic buffer sizing. Except Claudio's driver change still has bugs in it. So this is a huge paradigm change because it's the simplest interface we could invent for these drivers to follow, and yet we're having significant problems changing the drivers over. Hopefully we can get other people to buy into this idea and help us out of it.
Yeah. Is there anything else that people would like to talk about?
I could introduce some of my for example, I tried to solve this program I calculate for the CPU usage of both user and interrupt, and calculate free resources which I can use, and dynamically control interrupt rates. But I couldn't, not so good. And then I tried to control for example, IFO, do you know IFQ underscore Q? And I tried to check that there, and for example, ID Q is good or not, and I add hook I add a callback to Ethernet driver to control interrupt rate, but it effective but not so good. And then I tried to watermark into IFQ, and control between the low order and high order. But because we are not using real-time OS, so always higher interactive mode. So I couldn't.
So, Saito-san, it seems like you've been working on this problem for a while now. And you know now that the OpenBSD people are actually working on this. And I think you need to get involved with that. Really important. Yeah. So that we can wrap up quickly. For next year, does anybody have any suggestions on how we can improve this conference for next year?
I have a couple of suggestions.
I think I attended the Pro Conference YEPC Asia this year as well, and one thing that they do very well is they do a lot more bilingual stuff, and people are encouraged to give talks in Japanese. I know there were a few talks in Japanese here as well, and a lot of the English talks had the slides translated into Japanese, and I think that made it a lot easier for a lot of the participants. And also they had a few translators to do that kind of thing. So that's the suggestion. I know that the resources are limited, but
no, it's a good suggestion for sure. In fact, I think comparing from last year, I think there are more Japanese that have attended this year, so I'm really glad to see that. Are there any other suggestions anyone would like to make? David, yes? Oh yeah. Why are we using what? Why are we forced to use that? That doesn't make sense to me. But I have an interesting thing. Talking to one of the developers that came in several days ago, he had a problem actually getting money from ATM, and he asked someone about to actually help find an ATM, and apparently went to the ATM and it just didn't work. And it was supper time. And he just wanted to get money to buy his supper. And the Japanese individual that was helping him out, they didn't know him from a brick in the wall, yet he offered to pay for his dinner. And that's so typical of Japanese hospitality. And that's probably one of the reasons why Kirk comes back every year, even though he's not a plenary speaker this year. But I have to say that Japan is really a wonderful country, and I know that's why so many of the foreigners, the speakers, come back time and again, because every foreigner that comes to Japan goes away with such an impression that you make, and it's really wonderful. Oh, by the way, that dinner that guy received, well, the next night it happened again. And he's not looking for this kind of stuff, but I thought it was just wonderful. Anyhow, just to wrap this up, I'd like to thank, I've been behind the scenes, not doing very, very much, but behind the scenes knowing what's involved, and I'd like to give a big round of applause to Hiroki Saito, who, I don't know if he's in this room, but he really, really did a lot of work for this conference. So if we can all give him a big round of applause, and also please tell him so, because he's not in the room right now, but tell him so at the dinner time. Okay, so for Saito-san. Okay, and I think we'll just wrap it up here. And I believe dinner starts at 7 o'clock? Yeah? Upstairs? 6:30. Oh, 6:30 now? Oh, awesome. Oh, great. Okay, let's go all upstairs and eat. Great.